Hello, and thank you for stopping by to learn about science diplomacy in emerging economies, a topic that I will introduce to you through the study of the Colombian case. My name is Alejandra, and together with my colleagues Luisa and Ernesto, we developed a study to understand the landscape of conceptions, actors, practices, and suggestions associated with science diplomacy in Colombia from the point of view of key stakeholders. For this, we used a qualitative phenomenological approach combined with a case study, for which we carried out a series of semi-structured interviews to get a sense of the point of view of key actors. With the analysis of this data, as well as the revision of official policy documents, we developed a proposal of a governance framework based on the need to develop a policy mix for science, technology, and innovation and foreign policy in Colombia. The conceptual framework for the study includes the three dimensions developed by the AAAS and the Royal Society in 2010, as well as the concepts of promotion, influence, and access, as described by Flink and Schreiterer in their work. We also explored the approaches of science diplomacy used by various authors from the Global South that include case studies from different regions of the world and that highlight, among others, the importance of non-traditional actors in science diplomacy, the role of governmental support to produce and promote collaboration in science, technology, and innovation, the notion of capacity building in science diplomacy, and the exchange of intellectual and technological resources as essential for the insertion in the global science, technology, and innovation landscape. In the first part of the study, we focused on understanding the point of view of key stakeholders in Colombia regarding conceptions, actors, and practices associated to science diplomacy. 18 actors representing different science diplomacy stakeholders were asked their point of view as well as their suggestions for advancing science diplomacy in the country. The results suggest that conceptions are quite varied and mostly associated with the dimension of diplomacy for science and the concept of access, explained by different authors. Interviewees also indicated that actors lack spaces of interaction and therefore a common understanding of the concept. Among the suggestions provided by our interviewees was the need to generate spaces of convergence between the multiplicity of actors that play or may play a role in science diplomacy, which, according to our interviewees, may range from state and non-state actors from multiple sectors. Interviewees also mentioned a great number of practices that we classified in three categories. First, practices associated with building bridges and enabling collaboration. Second, those associated with capacity building and skills development. And third, practices associated with sharing and accessing resources for science, technology, and innovation, such as policy instruments, agreements, and infrastructure. After this analysis, we explored the most recent developments in the Colombian science, technology, and innovation policy, focusing on its international dimension. In addition, we also explored the main characteristics of Colombia's foreign policy to understand the current challenges, opportunities, their scope, areas of action, as well as the links between foreign and science, technology, and innovation policies in the country. As a result, we present a tentative governance scheme leveraged on the policy mix concept for a proper science diplomacy in Colombia. We argue that the public domain in science diplomacy in Colombia can be built using as underpinnings national science, technology, and innovation and foreign policy intentions and instruments. Our proposal then lays on 3 points. First, a multi-stakeholder effort is needed. Second, this effort should seek the development of a science diplomacy public domain and a state strategy about it. And third, the strategy and the domain must be constantly evaluated by the science diplomacy actors. The scope of our study only allowed us to propose a general scheme that we suggest should be complemented with a deeper look into the type of instruments that such a policy mix may include. Apart from a study on the instruments, further research questions relate to: first, ways to articulate within a science diplomacy strategy non-traditional and less visible actors, such as Colombia's scientific diaspora, subnational organizations, indigenous communities, among other actors with local knowledge. Second, how to identify national interests with global impact as part of that strategy. Third, how to guarantee the sustainability of a strategy and make it a long-term state policy. So here are the references we used for this video poster, and we really hope you take a look at our paper published in a special edition of Frontiers in Research Metrics and Analytics that you may access using this QR code. Thank you for your time and enjoy the INGSA conference.
La mondialisation a rendu plus complexe le processus de prise de décision au niveau des pays et induit à un rapprochement des compétences tant du côté des décideurs que des institutions. Côte Africa, un projet pour rapprocher scientifiques et décideurs.
Alors en fait, le conseil scientifique, c'est quoi? Ce n'est pas la science. En fait, c'est toute information, toute donnée probante qui peut aider le décideur à prendre une décision. Une décision politique ou une décision de politique publique qui puisse être la plus efficace possible.
Raison pour laquelle nous proposons un modèle de conseil scientifique innovant. Dans nos États, nous avons les institutions de conseil. Donc, ce qui est proposé, c'est que les experts, des spécialistes de 4 catégories, les scientifiques, les cadres du secteur privé, les cadres de gouvernement, les cadres de la société civile provenant des ONG, se regroupent sur une thématique de politique publique en action prioritaire.
Côte Africa, une nouvelle trouvaille, une initiative soutenue par les académies de tous les conseils économiques des 6 pays du continent.
Le Bénin, le Burkina Faso, le Cameroun, le Mali, le Togo et le Sénégal. Alors, il faut dire que son application dans ces 6 pays a été facilitée grandement par la forte implication de toutes les académies des sciences de ces pays.
Voici un modèle innovant qui permet aux décideurs de communiquer avec les institutions de conseil et ensuite avec les experts, donc les populations aussi, qui de manière inédite travaillent ensemble à émettre un avis commun. Cet avis comportera des constats et des recommandations sur la politique étudiée.
Les 2 thématiques retenues, l'employabilité des jeunes et l'entrepreneuriat féminin, sont des thématiques qui intéressent fortement tous les pays du continent en fait. Et donc les pays d'Afrique de l'Ouest et d'Afrique centrale qui étaient impliqués dans ce projet ont eu chacun à mettre en pratique des politiques publiques.
Le Conseil économique pour le développement de l'Afrique intègre ainsi le cercle de décision du continent pour apporter des contributions dans le domaine du conseil scientifique.
Le projet a montré le rôle important que peut jouer la coopération en matière de développement des sciences et de la technologie dans notre sous-région à travers des réseaux comme le réseau des académies d'Afrique, le NASAC.
L'académie fait partie de différents réseaux d'académies, des réseaux africains, des réseaux au niveau international, et il a les relations pour pouvoir faire appel à des scientifiques, vraiment sommité scientifique dans les différents domaines d'expertise et le recours à l'expertise nationale et internationale pour émettre des avis scientifiques motivés.
Puisque ce que nous recherchons, c'est les effets et les impacts visibles sur les populations par les actions publiques. Et lorsque vous considérez le premier groupe d'acteurs que constituent les décideurs, il faut dire que c'est eux qui élaborent les politiques publiques. Ce sont eux qui les mettent en œuvre et ce sont eux qui les évaluent.
Côte Africa est un esprit d'ouverture, une initiative qui permet d'intégrer d'autres thématiques.
En perspective, nous espérons la manifestation d'autres partenaires pour étudier d'autres thématiques, élargir cette plateforme à toute l'Afrique et aussi travailler à créer le nexus conseil, décision, évaluation.
Mais il est question déjà de pouvoir intégrer la question du conseil scientifique et surtout de la diplomatie scientifique au niveau local pour aider les maires des différentes communes d'être plus efficaces, d'avoir des décisions qui vont permettre d'améliorer réellement les conditions de vie de leur population.
Le projet a non seulement permis le rapprochement des académies et des conseils économiques et sociaux, mais aussi a permis de démontrer l'importance de la mutualisation des capacités d'autres académies. Et le colloque de Dakar, promis par le projet, a été une réelle occasion de promouvoir le conseil scientifique au gouvernement.
Voici comment nous comptons, à partir de 2022, promouvoir des ateliers de ce nexus, Conseil économique, gouvernement, Académie des sciences et Assemblée nationale, pour promouvoir le conseil scientifique en Afrique.
My friends say that I'm an indecisive person. I can't make a decision. For me, there are too many variables to consider, and this can confuse me and stifle my progress. But this is nothing compared to how complicated a natural system such as the environment is. It is impossible to predict with any certainty how this system will evolve and react to changes. And so how can we protect something such as the environment when the data we are dealing with is so uncertain? How can the data be used in a meaningful way? The Precautionary Principle, developed as a means of transforming scientific uncertainty into data that can be used in policymaking and legislation. There is no one definition of the principle, but the most recognised is probably that of Principle 15 of the Rio Declaration. Where there is a threat of damage, uncertainty should not be used as a reason not to act. At the EU level, the principle is enshrined in EU treaty law. The European Commission drafted a communication paper on the principle in order to give clarity to its application. The paper isn't binding, but it gave broad guidelines as to how to apply the principle, and responsibility was given to the Court of Justice of the EU to define the principle more precisely. The paper placed science at the core of the principle. So how does the court approach science and scientific evidence in the application of the principle? And what impact has its interpretation had on the use of the principle and the science that informs it? In my research, I've looked at decisions of the CJEU when dealing with the principle in the general area of environmental law. And in the following few minutes, I'll outline some of my findings. The court has recognised that scientific evidence is an important procedural guarantee. The communication requires the scientific data to be reliable and available. The court has interpreted this as requiring the best scientific information available or data based on the most recent results. It has given examples of how these criteria can be met, such as by using peer-reviewed data or established methodology, but these aren't infallible. There is often subjectivity in science and bias, especially when publishing, and using the most recent available results might not reflect what information is needed by society. It is a difficult area to define, but these terms are quite vague and bring no clarity to the definition of the principle or to the type of data required to apply it. The communication specifically refers to taking due account of minority science and contradictory evidence indicative of uncertainty. EU institutions rely on opinions of scientific advisory bodies who have to take minority science into account, but the EU institutions don't have to follow these opinions. So minority science might be taken into account by the advisory bodies, but might not make its way into the assessment of the best precautionary measures. Scientific data should be objective and independent. EU institutions usually request scientific committees consisting of independent experts to carry out the scientific evaluations, but, similar to minority evidence, the EU institutions are not bound to accept these opinions, and so decisions are being made without an independent, objective scientific basis. So what does all this indicate? The court does place importance on the scientific element of the principle, but it doesn't follow this through. There is no clarity as to the type of science that should be used in the application of the principle. There is no coherent approach, and this has weakened the role of science. And more importantly, it has weakened the application of the principle, rendering it ineffective and unable to fulfill its role in guarding society and the environment against potential risks. So how can we rectify the situation? We must recognise the importance of scientific facts in the application of the principle. and use the scientific data in a consistent manner. At a judicial level, the facts should be assessed similar to any other evidentiary requirement. And we need a more collaborative approach between the scientists and the legislature. The environment is a complex system, and we are all a part of it. The principle, if used effectively, can help us move forward and tackle the problems of today. But we need a collaborative approach, with science at the core.
So how do science advisors learn? Well, in many cases, academics have received training in science communication, for example. Others might have a decent idea of how science policy works before engaging. But for the most part, advisors learn on the job. Indeed, the job of advising can hardly be taught by a textbook alone. Like any adult learning in a professional environment, advisors' learning is situated, meaning it is inextricably attached to the environments they find themselves in. The type of environment will have a large influence on how advisors perceive their role and the norms that go with it. It can also be transformative, given how different it is to work in academia versus policy. Unexperienced advisors might find it challenging at first. They might need to re-evaluate some of their assumptions about the role of science in policymaking. In studying advisors' learning then, researchers might want to observe advice in action. Such observations could supplement other methods like interviews or surveys. This is what I did in the context of environmental policy advice in the UK. So what did I find? I found that the worlds of science and policy are indeed very different. They are like two distinct cultures. While one values veracity, the other values velocity. Discovering their similarities can equally be a learning process. With PhD students doing policy internships, I found ample evidence of culture shock. Like with any cultural encounter, advisors learn through embracing or even adopting some of the traits of the foreign culture. Anthropologists call these processes enculturation and assimilation. Advisors' learning varies with the model or ecosystem that science advice they're exposed to. I identified two models. Networked intelligence is the address book approach to science advice. Policymakers have their go-to people or organizations with whom they have relationships built on credibility and trust. Meetings are often ad hoc and informal. The emphasis is on the intelligence provided by the nodes of the network and the strengths of the connections between them. Learning is often erratic and unforeseeable. Advisors used to this model might equate influence with who you know. Collective intelligence is the whole is greater than the sum of its parts approach. Advice emerges through collective deliberation and compromise. It often comes in the form of formalized advisory committees. If conversations between committee members are open, honest, and in-depth, they learn a lot from each other. Chairpersons are key figures in facilitating that mutual learning. Finally, it takes a certain kind of character to survive and thrive in science advice. Some of my interviewees suggested that advisors need to be T-shaped, combining deep expertise in their research domain and a willingness to work outside of their immediate comfort zone. They need to be able to work across disciplines and talk to various kinds of stakeholders, for example. Knowledge brokers, committee secretariats, scientists and policymakers can be more mindful in designing meetings. A plug-and-play meeting format might not be as effective as a tailored one. In the collective intelligence model, emphasis should be given to the mix of participants and to the facilitation process. In the networked intelligence model, emphasis should be given to the balance between privacy and transparency and to the character of individuals. The Centre for Science and Policy in Cambridge is a great example of best practice for the latter. The pedagogical potential of simulations and role-play is currently underexploited. I ran and chaired a simulation of a scientific advisory committee with PhD students, which was incredibly effective at generating similar learning outcomes to those expressed to me by very experienced advisors. I also experimented with role-playing cards with master's students. I'm convinced that exploring different scenarios of science advice through simulations and games could achieve a great deal more than texts and talks. There are lots of exciting possibilities and lessons to be learned from studying advisors' learning, but the key message remains that in order to become an influential advisor, there's nothing quite like experiencing it for yourself. Thank you.
Managing natural resources involves getting scientists' research into the hands of those who need to make the decision. If we want evidence-informed decision-making, we need scientific knowledge as a crucial part of that equation. And that's what our research team is concerned with. Knowledge exchange. What are the means by which scientific knowledge moves from knowledge producers to knowledge users? So we set out to study the flow of knowledge between producers, scientists in our case, and users in the context of forest science, predominantly governments, but also indigenous governments, NGOs, industry, and many others. We did this through a systematic literature review, and we interviewed specialists in the Canadian Forest Service whose job is to facilitate knowledge exchange to understand their experiences. And I'm really excited to share our findings with you. Firstly, we found many terms have been used by people in the forest sciences to describe knowledge exchange. In our literature, we found 90 unique terms in English being used to refer to knowledge exchange, like knowledge transfer, extension, knowledge mobilization, and many more. But for the actual articles themselves, only 14% had anything to do with knowledge exchange. That makes it really hard to search for examples of knowledge exchange unless you already know what you're looking for. So with all these approaches being described differently, that means at least in the forest sciences, it's hard to categorize them, hard to measure them, and importantly, hard to understand if you're accomplishing the goal of moving knowledge between producers and users. So when we pulled together all the types of knowledge exchange we observed in our literature review, we were able to suggest that knowledge exchange can fit into a framework or a typology with 4 types of knowledge exchange. The first general type is one-way exchange. A scientist produces a paper or a report, delivers it to a prospective knowledge user. Some people call this the loading dock model or the deficit model, where the knowledge user often kind of has to sift through the literature to find what they're looking for. The second type is solicited exchange, where the knowledge user knows that they have a gap in their knowledge and they invite a producer to answer a predetermined question. You might hear terms like knowledge broker or boundary spanner who help link up producers and users, or you see this in, for example, calls for proposals to answer particular questions. Network exchange involves 2 or more people or institutions, they can be producers or users of knowledge or both, who are all sharing their knowledge that they produced independently. In fact, this conference in the International Network of Government Science Advisors is a great example of network exchange. And the fourth and final type is participatory exchange, where the prospective users are included in generating the knowledge from the beginning. Co-production of knowledge, this is often called. So we also interviewed knowledge exchange specialists at the Canadian Forest Service to see how their understanding of knowledge exchange lined up with what we found in the literature about forest science. And what we found was that even though specialists were located in different offices across Canada, working on different topics related to forestry and forest science, all of their experiences did fit into this 4-typology of knowledge exchange. And no matter what type of knowledge exchange they were using, they all framed it with some key components that were common. In every case, they described a sharer, someone who was generating the knowledge and wanting to share it, an audience or a user that they had identified that they wanted to share it with, and an activity to share it, like a presentation. And finally, an end product, like a report or a scientific paper. So all these components were common. So if our ultimate aim is evidence-informed decision-making, what's next? First of all, we need to develop a common language for talking about this. We recommend using knowledge exchange or échange de connaissances in French to allow for concepts that include multi-directional movement of knowledge, whereas terms like knowledge mobilization, it's only that one way. So to include participatory exchange, use the word knowledge exchange. We offer this typology, these 4 types of knowledge exchange, to help understand, where your situation or your project might fit and what might be appropriate. And then once you've classified your knowledge exchange activity or effort, the next step is to figure out what you're trying to do and measure if it worked. And that's something that members of our research team are engaged in and providing guides to do. So to find out more about our research, check out the websites shown here, or if you're on ResearchGate, search Understanding How Knowledge Exchange Operates. A huge thanks to our wonderful research team. This project is an example of collaborative exchange in action, and keep in touch with us to see where we're going next.
Hello, my name is Akoko Sita Kondo. I'm a PhD student at the Department of Anthropology and Sociology in Université Alassane Ouattara in Côte d'Ivoire, and a fellow in Africa One Aspire. I'm going to talk about my work on transforming research evidence on rabies into practice in Côte d'Ivoire. Translating research evidence into practice has become a priority for academics all over the world. However, many research projects still lack plans and funds to policy-related research dissemination and research uptake activities. Our study focuses on research evidence on rabies produced by Centre Suisse de Recherche Scientifique en Côte d'Ivoire. The general objective is to understand the transfer of research evidence into practice in Côte d'Ivoire. The specifics are: 1. To identify the mechanisms used by researchers to share evidence with policymakers and local communities. 2. To identify what facilitates research uptake. We use qualitative method through semi-structured interview and observation to collect data from researchers, policymakers, and community from Ministry of Health, Animal Health, and local committee members that are fighting against rabies. From this study, what do we find? Our findings show that the strategy used to disseminate research with policymakers are by writing policy brief, report, or using social media, or speaking at workshop, conferences, or a meeting. With the local communities, it's only on speaking platforms such as workshop restitution, sensitization, rabies day platform, radio, WhatsApp platform, and training. Also, the stakeholder engagement from the designing of the project has a long tradition at this transdisciplinary research hub. In terms of direct impact, we have higher dog vaccination coverage, more hints reach the animal and human health services, higher rates of observation of dogs, higher health center attendance, the higher reported cases of bites, raise awareness, improve community surveillance, and also an increased effectiveness of rabies control. As conclusion, a successful dissemination and uptake call for a well-defined audience and tailoring messages via appropriate means or channel. As recommendation, we suggest that a sharing platform be set up to create an interactive process between scientists, decision makers, and community. Thank you.